This is project 3, video number 2, the one in which we program it up. Let's take a look at what we got to do with this one. Got the outline of the steps. Alright, I'm going to create a function. It's not going to return anything. And I call it plot trajectory. And it takes 3 arguments. They were specified as launch height, speed, and angle in that order. We're going to launch height h, v0, and theta for the angle. End, tab over, and I'm going to need an AY minus 9.8. Then I want to calculate the time of flight. I'll call it TF. And that's equal to equation 1 below. Alright, minus V0 sine theta, all that stuff. Minus V0 times the sine. I want it in degrees, so I got to use sine d. If I just use sine, it assumes the angle is in radians. Sine d of theta. And then it's going to be a minus square root. Well, all this stuff has to be in the numerator, so I'm going to need some parentheses over here. Let's save this thing. Plot trajectory in my code. Okay. Square root of this quantity squared. So square root of, and then the first thing we have is the stuff squared. I think I'll leave it just like that for a moment so I can see it. And then it was minus 2 times AY times H. And then that's the end of the square root. And then that would be the end of the numerator, so slash a sub y. And then I did a copy. I should be able to paste this with a control V. Yeah, just saying it's that part squared. Alright. That gives me the... Oops, what was my warning there? Oh well. It gives me the TF. And get some extra spaces in there. I think it just makes it easier for me to read it. But then X, well, I need to create an array. T array is equal to linspace I use for that of 0, comma TF, comma 100. I'll try 100 points. See, that gives me a smooth curve. If it doesn't, I'll just jack it up. So then X array is equal to, let's look what we had over here. V0 cosine of theta times T. V0 times cosine in degrees of theta, and then times T array, and then Y array equals H plus V0 times Yeah, I better look that up. V0 sine of theta times t, and then plus 1/2 a sub yt squared. Sine d of theta times t, and then plus 0.5 times a sub y times t to the 2 power. Alright, now t is an array, and if I just raise it to the 2 power, it's trying to square that array, and I just wanted to square each element. So I put a dot in front of an operator that says do it on an element by element basis. So I read that as t dot squared, or t dot power 2. Then presumably I just plot x array, comma y array. Let's see what happens if I save that and then run it. Plot trajectory. Get 3 variables. I'm going to try to use roughly what you used in the lab when you were shooting it across the floor. 1/2 meter, I think you were in that ballpark. Probably, I don't know, about 1/2 meter I'm going to call it. I don't remember whether you were a little higher or a little lower than that. And then 35 degrees. So all kinds of, well, an error there involving t. And all kinds of errors, just an error. So I was supposed to call that t array. T array. Let's save that. Have another go at it. Wow. That looks like it's working. It's going about 4 meters, which seems reasonable in the lab. Highest it goes up is a little less than 1.2 meters. From my recollection, that's consistent with the projectile motion that you guys saw in the lab. That's why I wanted to pick those numbers. And here's my 0. Let me I want to try to fix that up a little bit. The command is wide limb. Wide limb values equals wide limb, and I'm going to go wide limb of, I want to go from 0 up to what the second value was there, of 2. So that's a close parentheses. These should all be y limb arg1 arg2, and then up here, I think if I do it this way, it tells me what it's using. I'll assign that to y limb values, and then if I just put y limb values of 1 and y limb values of 2 here, it would say to use the same 2 values that y limb values has, but I want to go 0 to whatever the automatic value was. So I'm going to at least try that. Save it. See if the desired effect occurs. Wrong number of arguments. Oh, I know what the deal is. I think I need wide limb to be an array of 2 values. So, or the argument, the argument, wide limb actually only takes 1 argument, but it's an array of 2 values. So presumably it gives an array of 2 values. This one. Let's try that. Apparently I already saved it. And the y-lim values it was using was minus 0.2 to 1.2, and presumably it's using the right ones now. Let's look at the graph. So yeah, it goes 0 to the automatically determined value. And xlim was fine. For some reason it started at 0 anyway. I guess I should try a couple of different trajectories, make sure that doesn't change, that x always starts at 0. So let's run this with started at 15 meters high, 60 meters per second, and let's go 48 degrees. We're printing some extra stuff to the screen. I better get rid of that. But alright, it always looks like a trajectory. This one goes a lot further since much higher launch speed, and also one higher, bigger angle with on top of the higher launch speed. So I'd say it looks like it's working. I'm gonna go ahead and put semicolons on there so I'm not printing extra stuff to the screen. Save it. Try running it. Okay, nothing extra printed to the screen. And let's try, make sure it's changed in the graph. So I want to try up arrow, and then I'll go over, change that to a 1, 15, and let's try a launch angle of 80 degrees. So it should go way high up. Well, not all that high, but it should go up and then come down without, I don't think it'll ever make it very far. Yeah, it only went 8 meters. There is some advantage to keeping the scale the same. I think this scale goes 0 to 10, and that one's 0 to 15. We could find out which is the max of the scale using that xlim and ylim idea to get these values, and then set the lower one equal to the higher one. But let's call it a video. We still have to fix this up. We have to put the range of the projectile, the height of the projectile, something like that, height versus range, or graph of trajectory of projectile. So we have to do the documentation and fix up the graph, but I think we've cracked the problem here. We've actually been able to plot the trajectory. So let's call this a wrap for video 2 from Project 3, Project 3 Video 2.